some interesting insights on byte addressability. So what is meant by this byte addressability? As we have seen earlier, we need to access the data in a sequential order, which means we can able to transfer the data bit by bit or byte by byte. So as you have seen in the earlier discussions, if you see this example here, the memory is of n bits of length. So the memory is of n bits. So n bit means it can able to transfer the data which is n bits at single point of time. Okay. What is the advantage if we are trying to do in that manner? So the simple advantage of that is we can able to transfer multiples of data in a sequential manner. So that's how we can able to do that byte addressability. Now let us look at what was the insights happening with byte addressability here. So this byte addressability can have the value from 8 bits. It can have the value ranging from 8 bits to 64 bits. Okay. So now let us look at the insights. It is practically difficult for us to assign distinct address to individual locations. Let us say we have 10 memory locations. So for each location, if you want to give the address, it will be difficult. Okay. As we have seen there in the diagram, each memory will take 8 bits. So after that, if you want to go to the next memory, we need to increment the program counter by 8 more bits. Correct? So it depends on the length of n. Length of n can be 8, 16 and 64. Based on its length, we need to increment those values. So that's how we are trying to function in the byte addressability. If you look at that, the most practical assignment is to have successive addresses which will refer to successive byte locations in the memory. Okay, so instead of incrementing it 1, 2, 3, 4 like that, with the length of 8, 16 or 32 or 4, 8, in that way it will keep incrementing it. So in this manner, we are trying to see the concept of big Indian and little Indian. So what was this big Indian, little Indian? You see the word itself will say that big Indian. There are two different ways the byte addressability can be assigned, which is like big Indian and little Indian. So when the lower byte address are used for more significant bytes, the least most bits of the word or address is called as big Indian. So what is the meaning of this? When lower byte addresses are used for the most significant bit. You see this one here, lowermost bit is what? This is the lowermost bit. Okay, these lowermost bits are used. So that's why it's called big Indian, which means if you see this here 0, 1, 2, 3, 4, the bigger value will be there in the LSB side and the smaller value will be there in the uh, MSB side. So that's why it's big Indian. Whereas in case of little Indian, it will be reverse, which means the LSB will have the least value, MSB will have the higher value. So this is how the big Indian and little Indian is going to function here. Okay. So now let us look at this example. We have hexadecimal address 2000. So how the data is getting stored there in 2000? If it is in big Indian format, it is going to store 0, 1, 2, 3 and 4, 5, 6 and it will go like that. It will be 2 power k minus 4 to 2 power k minus 1. In this manner, it is going to store. All right. If that is in case of little Indian, it increases from LSB to MSB or it decreases from MSB to LSB. So it's this way. So 3210. So this one is going to be used. Okay. So this is about the little Indian and big Indian. So word alignment. What is this word alignment? Why we need to align the words here? Let us look at that. The word length is typically multiple of 8. Usually the word length will be typically in the multiples of 8. So commonly what will happen is the CPU word length will be 8-bit or 16-bit or 32-bit or 64 bits. It will go in that manner. When this corresponding word length are more than 8 bits, let us say, usually it's 8 bits. If it is more than 8 bits, then what we need to do? We have to take a special care while accessing the words. So it is usually 8 bits, it will take care by itself defaultly. Fine. That is more than that. Let us assume that is 32-bit. We need to take a special care on that. In that case, for example, if it's 32-bit word length, then what we need to do is we need to have the word boundaries across the addresses. So across 0, 4, 8 like that, we need to have the word boundaries we need to have. So in general, to make us understand or to understand it clearly, the words are said to be aligned in memory if they begin at the natural word boundaries. So it has to align themselves in a natural boundaries when we are trying to address them. So the address of such words are called aligned addresses. This corresponding thing is called as what? Aligned address. So for instance, 16-bit word length aligned address are 0, 2, 4, and so on for 16-bit. If the words begin at an arbitrary byte address, then the address is called as unaligned address. Okay. So in this way, the word address has to be maintained. So is that example clear to you? One more example, we'll get that here. If 16-bit word we have, the word address has to start either with 0 or with 2 or with 4. If somewhere it is starting with 3, then we call that as what? Unaligned word address. So if you start with 0, 2, and 4, it's called as word aligned address. If it is starting somewhere with 3, that is called as unaligned address. Similarly, for 32-bit word length, what we can see here, it has to start with 0, 4, and 8 so on. If it starts somewhere with 2 even, it's not word aligned. In case of 64-bit, it has to start either with 0, 8, or 16. Any of the number it starts with 1, 7, like that, that is called to be not aligned. Okay. Now, let us look at the accessing the numbers and characters and its strings. How do we access the numbers and their characters and its strings? Okay, so let us look at that. So we have seen the numbers which are stored in memory as word. Usually the numbers what we have will be stored in the form of a word. Okay. Thus it can be accessed by specifying its word address. We can able to specify that by using its word address. Okay. And on the other hand, the character is stored in memory as byte and its accessibility by specifying its byte address. So we are able to see that. Now, in case of this, the character string is stored using successive memory locations in the memory. Since the character strings are available with variable lengths, we have to specify two things about the strings. First thing, starting address of the string. Second, length of the string. One is starting address, second is length of the string. Okay, there are two ways to indicate the length of the string. What are the two ways to indicate length of the string? First one, a special control character with the meaning of end of string. So if a string is completed, if you're able to specify the string is ended, we can able to understand that. That is one method to understand the string is completed. And we can also be use the last character of the string, or we can have a separate number is used to specify the length of the string. Let us say I mentioned 10. So after 10, the string is going to end. So that's what the meaning of that will be. Okay, so thus the string can be accessed by simply specifying the addresses of the first byte of the character, or by specifying the starting address and the number indicated the length of the string, which can be in a separate word location or in a processor register. So to summarize this quickly, what is that we can understand? The string length can be understood by two methods. One is we have to mention that end of the string. Second option is what? We will mention the length of the character used by the string. So any of the way we can able to complete this task. So that's how we can able to access the numbers and strings. So, okay. One special control character with a meaning end of the string is one point what we discussed. This is one set of thing. And or a separate memory word length or a processor can contain a number of indicating length of the string in bytes. Any of these methods we can able to do it. So that's how we can able to do. The next session we'll discuss upon memory operations. So thank you.